Dear student, and welcome back to my channel, that is Easy Chemistry by SBG. So today we will solve again a combined problem based on a UV IR and NMR spectroscopy. So let's see the problem number 1. The molecular formula is given, that is C4H9Cl. IR data is provided 790 per centimeter. Then PMR is given. The PMR first value, triplet for 3 hydrogen at 1.02 delta value, quintet for 2 hydrogen at 1.71 delta value, doublet for 3 hydrogen at 1.50 delta value, and sextet for 1 hydrogen at 3.97 delta. So let us solve the problem. So first step to solve the spectroscopic problem is, if we have the molecular formula, then first step is to determine the site of unsaturation. So we have the molecular formula here, that is C4H9Cl. Let's calculate the site of unsaturation. Site of unsaturation. As in previous lecture, already we have seen how to calculate the site of unsaturation. We have the formula to calculate the site of unsaturation, that is 2 into number of carbon plus 2 plus nitrogen if there, minus number of hydrogen and number of halogen upon 2. So in given molecular formula, there are total 4 carbons. So 4 into 2, 8, 8 plus 2, 10. There is no any nitrogen, so 10, minus the total number of hydrogens are 9 and 1 chlorine is there, so minus H minus X, so total 10 minus 10 upon 2, and it comes 0. So the given organic compound is a saturated organic compound. So we can write, if the site of unsaturation is 0, means no unsaturation is there, means the given organic compound is saturated organic compound. So this is the first step to determine the site of unsaturation. Now let's see if any UV value is there. So no any UV lambda max is given here. So second is the IR value. So only single IR value is given, and it which is at the 790 per centimeter. So 790 per centimeter value indicates the presence of carbon and chlorine. This 790 per centimeter is the stretching value of the carbon and chlorine bond. So it indicates the presence of carbon chlorine bond. Then let's observe the PMR data carefully. The maximum information we get from the PMR data. So first, triplet for 3 hydrogen. Triplet for 3 hydrogen. So these 3 hydrogen must be on the one carbon, and it gives the triplet. Triplet means they must be attached to the next carbon. This carbon must be attached to the next carbon, where that carbon carries the 2 hydrogen. So that hydrogen will give the triplet. Sorry. This hydrogen, 3 hydrogen will give the triplet value at 1.02 delta value. Then second, this is the first. We can name it as a A. So A. Then B. If we see the B, quintet, the 2 hydrogen, CH2, these 2 hydrogen gives the quintet. Quintet means 5 signal. 5 signal means it indicates the presence of total 4 hydrogen. So 4 hydrogen may be like this. 4 hydrogen may be like this, or The second possibility is CH2 must be attached to the CH3 and CH. So these two possibilities are there. Means these hydrogens, that hydrogen shows the quintet. Quintet means five signal. As we know that the singlet means one signal, then doublet means two, triplet means three, triplet means three, quartet means four, and quintet means five, and sextet means six signals are there. So the two hydrogen, the second value, two hydrogen gives the quintet at 1.71 delta value. 1.71 delta value indicate that hydrogen that CH2 group must attach to the other carbon, and so most convenient is this one. If this CH2 shows the quintet at 1.71 delta value, because there is a no presence of, from the given data, from the PMR data, there is a no any proof for the existence of the 3 CH2 group. Means one CH3, two CH3s are there here, three hydrogens, three hydrogen, group of the three hydrogens, two groups of the three hydrogen, and one group of two hydrogen, and one single hydrogen is there. Means no presence of 3 CH2 in our structure. So the second is the most convenient, means CH3, CH2, CH is there. Then third data, doublet for 3 hydrogen, C. Doublet for 3 hydrogen. Means again the group of 3 hydrogen which gives doublet. It means that 3 hydrogen or this CH3 is attached to the carbon which carries the single hydrogen. So structure will like this. So this hydrogen gives the doublet, and at 1.50 delta value. And another remaining one hydrogen that gives the sextet. Sextet means that a hydrogen is nearer to the 5 hydrogen. So as per the n+1 rule, the number of hydrogen present next to that hydrogen neighboring carbon carries the number of hydrogen will give the +1 signal. So this hydrogen, if we consider, so this hydrogen gives sextet at quite de-shielded, this one 3.97, means presence of this framework CH3CH, and this CH is attached to this CH. This CH is attached to CH2 and this CH2 to the CH3. So this will complete the framework. Now though if we consider the valency, so valency of this D1, fourth number carbon, is incomplete, and that valency will be completed by the remaining functional group, that is the chlorine is present there. So let us write the structure. Let's connect these fragments. So we'll get the most clear structure. CH3, CH, this CH3 here, then CH, then this CH is next to the CH2. So CH2, and this CH2 is joined to the CH3. So second number carbon will carries the chlorine. So this will correct structure matches to our spectroscopic data. If we write the data, then this CH3 will shows the triplet, because its next carbon having the 2 hydrogen, so triplet. These hydrogens will shows 3 plus 1 4, so it will shows the pentet, or we call it as a quintet. Quintet means 5 signal, and this hydrogen, single hydrogen, shows the sextet. as its next carbon carries the total 5 hydrogen, and this CH3 shows the doublet at 1.50 delta value. If we match the delta value, then this triplet at 1.02 delta value, and this CH3 is quite deshielded at 1.50 delta value. This sextet shows at the 3.97 delta value, and quintet we get at the 1.71 delta value. So this is a perfect structure for the given spectroscopic information, and all data are matched here. And IR value that suggests the stretching frequency for the carbon and chlorine bond. Let us see the next problem, where the molecular formula is C9H10O. UV is given 265. So UV value indicates UV value is a 265 indicates the presence of benzene ring. Then IR is given 1619, 1500, 1600, 700, 750 per centimeter. PMR data is given. First PMR data is singlet for 5 hydrogen. So this spectrometer is a low resolution spectrometer. That's why all the 5 hydrogens will shows the singlet here. And we know that the singlet for the more than 4 hydrogen at in the range of 7 to 7.5 indicates the presence of benzene ring. Then quartet for the 2 hydrogen at 2.5 delta value, and triplet for 3 hydrogen at 1.1 delta value. So let us see. So step by step, first step is to determine the site of unsaturation. So let's count the site of unsaturation. We have the formula site of unsaturation, 2 into number of carbon plus 2 plus nitrogen if there, minus hydrogen minus halogen upon 2, so is equals to, there are 9 carbon, so 9 into 2, 18 plus 2, 20, minus no any nitrogen, so minus number of hydrogens are 10, no any halogen upon 2, so it comes is equal to 5. So there are total 5 sites of unsaturation. Sites of unsaturation. Second step, let's observe the IR stretching frequencies. Before that, the UV at 265, UV at 265 indicates presence of benzene ring, indicates presence of benzene ring, and IR values and the PMR data is also matches to the benzene ring. Then next, if you observe the IR values, then stretching frequencies in between the 1600 to 1700 indicates the presence of a carbonyl stretching bond, means presence of the carbon oxygen bond. So the IR stretching at 19, IR peak at not 19, 1619 per centimeter is indicates the presence of carbonyl group, because C double bond O group stretches in between the 16 to 1700, and this is quite lesser value. 1690 is quite lesser because there may be the presence of conjugation here. Then presence of this 1500 and 1600 values, these two values indicates the presence of benzene ring again. aromatic stretching. Then peaks at 750 and 700 per centimeter indicates the benzene ring, and this indicates the monosubstituted benzene ring. This is a very informative value in the IR. IR peaks at 700 to 750 per centimeter indicates the monosubstituted benzene ring. Monosubstituted benzene ring. Let us see the further data, PMR data. As we have already discussed that the singlet at 7.2 delta value for 5 hydrogen definitely indicates the presence of benzene ring, and 5 hydrogen means only one site is a vacant, that is a monosubstituted benzene will be there likewise, and this 5 hydrogen shows singlet. If you have the high resolution spectrometer, then that singlet will again split into the triplet. Let us see the further data, that is a quartet. Second is quartet. This is our first data. Then second is quartet for 2 hydrogen. Quartet for 2 hydrogen. This 2 hydrogen must have the 3 quartet means 4 signals. So that hydrogen attached to the carbon, that carbon must attach to the neighboring 2 carbon or a single carbon that carries the hydrogen. So there may be the possibilities of presence of either CH3 or CH2 may attach to the CH2 and next CH likewise. But the spectroscopic data provides that there are only 9 hydrogen, 9 carbons. So 6 carbons are a benzene ring, 1 is the carbonyl. So remaining 2 carbons are there. So these possibilities are eliminated. So presence of only these groups are left. And if we match the remaining spectroscopic PMR data, then this hydrogen, if this hydrogen shows the quartet at 2.5 delta value, then the next carbon carries the 3 hydrogen and it shows the triplet, because these hydrogens attached to the carbon, that carbon next neighboring carbon carries the 2 hydrogens. So this hydrogen shows the triplet at 1.1 delta value. And if we see the quartet of this CH2 group, then this value is quite de-shielded, that is 2.5. So the carbonyl group must be in between this benzene ring and this ethyl ring. So let's attach the fragments we have sorted. So the structure may like benzene ring, C double bond O, CH2, CH3. So if we match the spectroscopic data, then this will give the triplet, and here quartet, and the other 5 hydrogen of the benzene ring, they are showing the singlet at 7.2 delta value. So the resultant structure matches to the spectroscopic data. Site of unsaturations are also matched here. Total sites of unsaturations are 5. So benzene ring carries the 4 site of unsaturation. Benzene ring, 4 sites of unsaturation, and this carbonyl group one site of unsaturation. So total 5 sites of unsaturation also matches. Let us see the next numerical next problem based on the same topic. Molecular formula C7H8O. Then IR stretching frequency is given here 3500, 3030, 1600, 1500 and 1100 per centimeter. The PMR data is given. First, singlet for 5 hydrogen at 7.2, again that indicates the presence of benzene ring. Then singlet for 2 hydrogen at 4.4 delta value. Then singlet for 1 hydrogen at 3.7 delta value. So let us solve the given numerical. Step first, let's count the site of unsaturation. So site of unsaturation, we have the formula 2 into carbon plus 2 plus nitrogen if there, minus number of hydrogen minus number of halogen if presence upon 2. So is equals to number of carbons are 7. So 7 into 2 14, 14 plus 2 16. So 16 minus, here are total 8 hydrogens, no any halogen upon 2. So is equals to 16 minus 8 upon 2. So 4 sites of unsaturation. Therefore 4 sites of unsaturation. There may be the presence of benzene ring. Let us see the further IR data. Now first value of IR 3500 indicates the presence of either. Now this stretching frequency rate indicates the presence of either NH or OH bond. But here this peak is a broad peak and it is given here. It is a broad peak. Broad peak indicates the hydrogen bonding. Broad peak indicates the hydrogen bonding, means the peak at 3500 per centimeter value indicates the OH stretching frequency, means presence of the OH group. Only single hydrogen is there and single hydrogen, and if that hydrogen presence as the OH, means definitely the alcohol is there. And stretching frequency at 1100 per centimeter also indicates the presence of alcohol, means carbon oxygen. So peak at 1100 per centimeter indicates the carbon and oxygen single bond stretching. And this 1600 and 1500, these two peaks indicates the presence of the unsaturation, means presence of the aromatic ring, benzene ring. Let us see the PMR data. So first PMR data, singlet for 5 hydrogen at 7.2, means mono substituted benzene ring is there. So first, second, third, fourth and fifth. So this 5 hydrogen will show the singlet here. Singlet at 7.2 delta value like the previous case. Then second PMR data, where the 2 hydrogen shows singlet. 2 hydrogen shows the singlet. And already the only 7 carbons are there, means 6 carbons are engaged in the aromatic ring. So remaining 1 carbon is there, and that carbon carries the 2 hydrogen, and that 2 hydrogen shows the singlet at, these 2 hydrogen shows the singlet at 4.4 delta value. Now 4.4 delta value is very de-shielded value, It indicates the presence of the electronegative atom just bonded to the CH2 and C. This fragments is also matched, and this hydrogen will show the singlet, and chemical shift for this value is 3.7 delta value. It's also de-shielded, quite de-shielded. If we join the fragments, then we will get the structure of our resultant alcohol. CH2OH. And if we match the spectroscopic data, then this hydrogen shows the singlet at 3 point delta value. This second hydrogen, this 2 hydrogen again shows the singlet at 4.4 delta value, and the remaining benzoic hydrogen, they also shows the singlet at 7.2 delta value. The presence of broad peak in the IR data indicates the presence of alcohol or acid. So only single hydrogen is there, means 100% alcohol is present, and see the site of unsaturation are also matched. So in next lecture we will see the symmetric structure, how to solve the spectroscopic problem if the structure is a symmetric, and if we have the picture of the spectra. If you have the picture of spectra, from the picture of spectra, how to calculate the number of hydrogen, how to integrate the spectra, and how to solve the problem based on the picture if we don't have the data directly given. So we will see the in next lecture. Till that time, please share, subscribe and press the bell icon. So whenever I add the new video, you will get the notifications. Thank you.